Hi everyone, welcome back to Geeks for Geeks practice. So quickly give me a plus one in the chat if my voice is clearly audible to everyone and everything is working fine so that we can start. Hi Rishit, hi Vanchika, hi Naikaj, hi Abhishek. So all of you can quickly give me a plus one in the chat if my voice is clearly audible, and then I will share my screen as well. Okay, for the problem of the day. All right. So this is my screen. Let me change the format. Okay. So hi Chandrasekhar as well. Okay. So hi Harshvardhan. Hi everyone. Hi Tushar. So all of you can hit the like button first of all, and just make sure to give me a plus one if you haven't, and then I'll start right away with this particular problem. Okay. So I can still see the number of likes are less compared to the number of people. So you can hit the like button if you haven't. Okay. So this particular problem was the problem of the day for yesterday, you can say, because now it's 12 p.m., 12 a.m. in the morning. So this was asked in Amazon. Okay. So this particular problem that has been previously asked in Amazon. First thing. Now let's quickly see what was the problem of the day actually. So it says that they will give me a positive integer n. Okay. So what will be given to me is a positive integer n. Let's say they give me n is equal to 3. Suppose they give me n is equal to 3. Now I have to find out all the unique ways, all the unique partitions you can say, such that I can represent n as a sum of positive integers. Can I say that when they give me n, so one of the ways to make n is that I can only take 3. Okay. Another way is that I can take 2, then I can take 1, right? 2 comma 1. Okay. 1 comma 2 and 2 comma 1 is the same thing because I'm considering only it as a set, not as a permutation. Okay. Now another way could be that I can take 1, 1, 1. Is this part clear to everyone? This question, like if I take n is equal to 3, okay. So one of the ways for making n is equal to 3 is that I can take 3, okay. Then another approach is that I can take 2, 1, right? Another approach is that I can take triple 1. Now you will say that I could have taken 1 comma 2 also, like I could have first taken 1 then 2, but we are not considering permutations. We are considering the approach in descending order, all the unique possible ways. Is this part clear to everyone? If n is equal to 3 is given, then one of the ways to make this particular sum is that I can directly take 3, or I can take 2 comma 1, that will make 3, or I can take 3 ones, that will make 3. Is this part clear to everyone? Okay. Now can I say that I have to try what? I have to try all possible ways, right? I have to try all possible ways. And when I have to try out all possible ways and I have to consider this thing, then which approach, which technique comes to my mind? Just quickly tell me in the chat what comes to your mind when I say that all possible ways. When you have to consider for all possible ways, then recursion will come to your mind, right? Recursion. All possible ways is nothing but recursion. Okay. Now how is the answer expected? So if you will read the all possible ways is nothing but recursion. Okay. So you will see the generated output printed without partitions. So each partition must be in descending order. So you can see that in this particular example you can see that 3 is there, right? 3, because the sum I can make the sum 3 with just 3. Then I can have 2 comma 1. Okay. So if you will see, the basically what I have to return is, if they give me n is equal to 3, right? So one of the ways is that I just have 3, okay, or I can have 2 comma 1. Obviously I have to return the answers in descending order. So first of all this answer, then 2 comma 1, okay, then I can have 1 comma 1 comma 1. These will be arrays, or you can say vectors, and they will be stored in a vector of vector, or you can say array list of array list. Is this part clear, that how the answer is expected from you? Okay. So what can I do? I can simply say that we can simply use recursion technique here. How? So what we can do here is, first of all, we can say that we want to do what? We want to return our answer in array list of array list. Please write list of list in the chat, LL in the chat. I want to return the answer in a list of list or array list of array list, right? So you can see this is the return type. So what I will do here is, I will first of all declare a vector of vector, that is vector of vector, and it will be like int, and I will say it as answer, right? I'll name it as answer. Okay. And when I say this thing, that this is one of the answers, right? This is one of the vectors, right? This is one of the possible answers. then this is another possible vectors, another possible way of making the sum as n. This is another possible vector, right? So I will have a temporary vector, let's name it as v, that will be storing all the possible approach, like all the possible combinations, right? Like let's say 3, 2 comma 1, 1 comma 1 comma 1, like that will make the sum as n. All right, is this part clear to everyone, guys? Till this part, everyone is clear or not? Just quickly let me know in the chat. Is everyone clear till now? I'm still waiting for the responses in chat. Okay. So for that, what I will do is I will have a vector of int, let's say v, right? Then I will be writing a recursion. So recursion will be like this. Recursion will not have a return type, because whatever answers I'll be generating, I'll be whatever array list I'll be generating, I'll be storing them in the answer. Okay. So what I will do is I will have this recursion. Okay. And initially in this particular recursion, I'll be I'll say that, okay, what will I say? So I'll say that I will pass the current vector v, let's say the empty vector v. Okay. I'll pass the answer vector, that is the array list of array list. Another thing that I will pass here is this particular thing. Let's say the total sum that I want to make. So initially, can I say that overall I want to make the total as n, correct? And initially, what are the possibilities? What are the numbers that I can take, right? Guys, understand this thing. If n is equal to 3, so can I say that this is the overall total sum that I want to make, right? Total sum that I want to make, right? So I will let's say if I have total is equal to 3. Okay, let's say if I take value 2, okay, then the total will decrease by 2, so the total will now become 1. Okay, then after that, let's say I take 1, so the total will become what? Total will become 0. So the moment my total becomes 0, please write 0 in the chat. The moment my total will hit 0, okay, by taking some values, by taking some integers, the moment my total will become 0, that will be counted, like that will be counted as a way. No, let's say if I've taken 2, 2 is stored in my array, then 1 is stored, like basically this particular combination, taking 2 and then taking 1, if it is stored in my answer, right, like if it is stored in my current vector v, so that will be stored in the list of list. Now, is that clear to everyone? This part is clear. This particular thing will be stored. Is it clear to everyone, guys? Quickly let me know in the chat. This particular part is clear. All of you can quickly write a clear in the chat. Yeah, we store answer in vector answer, yes. So what will I do? I'll say that, okay, I'll have the total, and from which value can I start taking? If they give me n is equal to 3, okay, so can I say that the first value that I can start taking from is nothing but I is equal to n only? I can take it from 3, right? I can take it from 3. Let's say if I have to make a sum, like let's say if I have to make n is equal to 3, so I can start taking from 3, then I will be equal to 2, then I will be equal to 1, but basically I will be starting from n now. So what I can do here is I can say that I will start from nothing but n here, right? This is the current value that I'll be taking. Now I will pass this particular I value and I'll pass this particular total as well. Okay. Now after this, when my answer will get updated, after this recursive call, when my array list will store all the list, right? Or list of list will store all the list, or you can say vector of vector, then I'll be simply returning this answer as well here. Okay. Now what will I do here? I'll have this void recursive call because it will not return me anything. Okay. So what I'll have here is, first of all, I'll have the vector int. Okay. And I'll have vector int ampersand, you can say the vector v that I'm having, right? And then I'll have the vector of vector int answer. Okay. After this particular thing, what will I have? I'll have the current value that I want to take, and I'll have the total as well. Okay, these are the values that I'll have. Now, what is the base case? Guys, tell me, what is the base case in this recursion? Anyone can tell me what are the base cases that we can think of in this particular question? Just quickly let me know, guys. Can you think of some base cases in this question? Like any base case that you can think of, right? Understand this thing, that if, like, suppose that I had n is equal to 3. Okay, so basically if my total that I wanted to make was 3, okay, suppose that I take 2. Suppose that I take 2, so I'll store it in my array obviously, and then I take 2, so the total now becomes total gets updated to 1. Then suppose that after that I take 1, so the total will become what? The total will become nothing but 0. The moment my total hits 0, so 2 comma 1 is stored, so I'll store this in the answer, right? Array list of array list, basically, right? Basically 2 comma 1 will also be stored, right? Let's say if initially you can think of, like, if my total was 3, if I take 3 only directly, then my total will become what? 0, right? So the 3, the array which is having just element 3 that will be stored, then 2 comma 1 will be stored. Okay, yeah, value reaches 0, correct. So we will do what, I will do what here, like I will simply say that if it happens that my total is equal to 0, if my total, like if the value that I want to make, if I've made it, then I can simply do what, I can simply say that in my current list V, this whole things that I've taken, the all values that I've taken, for that I've used, like 2 is used, 1 is used, so this is stored in the array V, that is named as V. So I will simply store this in the array of array, right? So you can say list of list. So basically, I'll do answer dot pushback v, okay, and then I'll return from this particular recursive call. Is this part clear to everyone? Till now, everyone is clear, okay? Is there any other way that we can, like? Is there any other base case that you can think of? Is there any other base case that you can think of, guys? There's another base case, right? Suppose that your total is, let's say, something like randomly, let's say your total, still you want to make 2, okay? And suppose you had I is equal to n, I is equal to n minus 1, 1 by 1, you keep on decreasing, and suppose your I reaches 0. So this means that after this point, you cannot take anything, right? When my I is equal to 0, guys, understand this thing, that if my I becomes 0, if I cannot take anything, right? If like basically, if I'm taking I is equal to n, like suppose I'm taking I is equal to 3, I'm taking I is equal to 2, whatever, this kind of stuff. But the moment my I becomes n, let's suppose that total was 5. Suppose that somehow my I keep on decreasing my I, and I becomes 0. So in that particular case also, I have to return, because after that I cannot, if this much total is still left, okay, and I cannot take anything, like I have I is equal to 0, so I cannot add anything further, right? So if my I becomes 0, then also I should return from this particular recursive call. Is this part clear to everyone? We check, like we need to check that if I is equal to 0, then we will simply return, okay. Now what happens, can I say that in recursion, right, in recursion what can we do, like if I have this particular thing, right, if I have, let's say, we have the total, right, let's say we have the total as 3. So let's say we want to make the total as 3, okay. So let's say we'll start from I is equal to n only, like this is n only, let's say I is equal to 3, okay. So can I say that I can, in recursion what happens, in recursion, could you please explain I is equal to 0 case again? Yes, I can explain that. Okay, Rishit, understand this thing, right? Understand this thing. Suppose, Rishit, that you had to make I is equal to, let's say, something like 5, okay? And your I value was equal to 3. Or let's say your I value was equal to 2, okay? Then what happened? You took 5 minus 2, okay? So let's say your total value that you wanted to make was this much, okay. Total you wanted to make was 5. Now if you wanted to make the total as 5, so let's suppose you had I is equal to 2, you take this I is equal to 2, so now your total will become what, total will become 3, okay. Now let's say you reduce your I as well, suppose that you reduce, although you can or cannot, now I will become 1, let's say you use this one also, now the total becomes what, total is now 2, let's suppose you decrease your I again, so I is equal to 0 now for this case. Now you'll understand that now you cannot take anything further now, because you cannot take any coin further, or you cannot take any number further now when I is equal to 0. Now this total is still left, but you don't have anything to spend. You don't have anything to make this particular value, correct? So that is why you will simply return now, because currently you are having 2 comma 1, but that is not able to make the final answer, no? That is why. So if I is equal to 0, then you'll simply return from there. Okay, now understand this thing, guys, understand this thing. Like if I will say, like initially, let's say I have like let's say at a particular point of time I have the total, right? Let's say the total is 3. Let's suppose that I value is also 3, okay. And I have currently the array, like you can say that currently the vector v is, let's say, empty, okay. Now for a particular like you must have seen this thing in recursion, either I can take a particular value or I can skip it, correct? You know this thing, that is why the recursion is always exponential in nature. Either I can take I is equal to 3, because see, if you consider this way now, like see, one of the subsets that I can have is, like if I'll draw it downwards, so one of the subsets is like one of the ways is 3, or other way is 2 comma 1. So can I say that for a particular value, if I either I can take it or skip? Please write TS in the chat if you're clear with this thing. Either I can take a particular value or I can skip a particular value, correct? Is this part clear to everyone? Either I can take a particular value or I can skip. Please write TS in the chat, guys, if all of us are clear, and hit the like button if you haven't already. Is this part clear to all of us, that either I can take a particular value, like because you can see, either I can take I is equal to 3 in my answer or I can skip it, Okay, so this is one thing that I can do. Now if you'll observe, like if you'll observe, so like you can do this thing, right? So what can you do? Like you can do it like this. Like let's say you are skipping it. Like let's say you skip it. Okay, let's say you skip it. If you skip it, right, if you don't take this, right, then your total will remain the same. Na? Then your total will remain the same. So and you will try to move to I is equal to 2 then, right? You will try to move to I is equal to 2, correct? To one value lesser. So you'll try to move to I minus 1 now. So what I'm saying is that if I don't take it, then I can call the recursion. Okay, what can I do? I can call the recursion and I can call it for I minus 1. Okay, I can call it for I minus 1. Like basically I'm saying that I'll pass the vector as v because nothing I have taken. Okay, I'll pass the answer because answer is also not updated, so no worries. Then I minus 1 I'm doing because I'll move to a lesser value. Okay, and the total that I want to make is still the same. Okay, is this part clear? This is one of the ways. Okay, and since I want to make the answer in decreasing order na, so I'll call this recursive call later on. Okay, is this part clear? This is for the skip, when I'll skip the ith, like when I'll skip the ith guy. Is this part clear to everyone? This is when this recursive call is what I'll be doing when I will be skipping the ith guy. Okay, but I can also take it, right? I can also take the ith number in the current array v, right? Current array v. So what can I do in that case? So if you will see here, like suppose that you have this particular thing here. Okay, so in this particular case, now what can you do? Like if suppose you were at I is equal to 3, like suppose that you had I is equal to 3 here. Okay, if you had I is equal to 3 here. So if you had I is equal to 3 here, so what can you do? Like let's say this is the total. Okay, so if you had I is equal to 3, let's say you take 3, like if you take 3, then you will say that okay, now my vector will get added with 3, right? You'll get added with 3 and the total will decrease by the I value. So total now becomes 0. Here in this case, the total obviously becomes 0. So can I say that when the total will become 0, this answer will be stored in the final answer, right? So this 3, this array 3 will be stored in the final answer. Let me name it as answer. Okay, let me name it as answer. Let's say this is answer and this will be stored. Okay, this particular thing is going to get stored here. All right, this is what is going to what is going to happen. Now after that, can I say that if I do this, right? So see, when can I take a particular value? Also one more thing that you need to understand. Suppose that for a second, suppose that my total was equal to 4. Okay, some at some point of time my total was equal to 4 and my I was equal to 5. Can I take this? Can I take this 5? If my I is 5, can I take this 5? If I want to make the total as 4, can I take this value 5? Obviously no, I cannot take this 5. Please write no in the chat, guys. Can I take this 5? No, no, I cannot. If my total that I want to make now, let's say there's a particular sum that I want to make 4. Now can I take this I is equal to 5? No. So what can I do? I if I can take the ith guy if the ith guy is less than equal to the total. Now then only I can take it. Okay, then only I can take it. If the ith guy, okay, then only I can take it. If the ith guy is less than equal to the total, then only you can consider to take it. So what can you do here? So we are saying that if I is less than equal to the total, okay, in that case only you can take it. So you'll say that okay, I'll call the, like in the, like I'll say that v dot pushback in the current vector will push back what? Will push back I, right? Will push back I, correct? That is what we will do. And then after that, we'll pass the vector v, we'll pass the answer as well, and I will say take same, I'll pass same I. Why I'm passing same I? Because if suppose that I wanted to make, let's say the total that I wanted to make was, let's say something like 9. Okay, so and my I value was 3, suppose for a second. So can I say that if I have taken, like if I have taken 3, then I can take 3 now. So I can take a particular I multiple number of times. Is that clear? So that is why I am passing the same I in the next recursive call. Is this clear? Please write I in the chat. Is this clear? That is why I'm passing the same I. That is why I am passing the same I, because I can take it. I can take it again, right? I can take it again. So that is why I'm passing the same I, because maybe in future, if it is available, then I can take it. Okay, if my I is still less than equal to total, so I can still think of taking it. Okay, and then I will also pass the total. So what will be the new total, right? I need to pass a new total. So if there's a particular total, right? If there's a particular total, Let's say the total is, let's say, 5, and suppose that I was equal to 2. So in that case, if I've taken this particular 2, right, suppose in my answer, like answer vector v, so obviously that this will decrease by 2, right? So this will be, I'll pass what, I'll pass the new total as nothing but total minus I. Okay, now is this enough? No, this is not enough. Why? Because if you will consider for this case, suppose that the total that you wanted to make was 3, okay, and your I value was equal to 3. Now what you will do is, let's say, and suppose in this particular case, your vector, like let's say v was empty. Then if you take I is equal to 3 here, right? So suppose you take I is equal to 3 here. All right, you like, let's suppose that I value is 3, right? So you take I is equal to 3. Let's suppose that I am also writing I is equal to 3. Okay, if you take I is equal to 3, then what will happen, the total will become 0. Okay, and this particular vector will be now 3, correct? This vector will store 3, and since the total becomes 0, so you will do what, in your answer, inside your answer, you will simply store this particular vector v. So you'll store 3. Please write 3 in the chat in brackets. Is it clear? Is it clear to everyone? You will store this particular 3. Correct? Now, can I say that your vector v is having this 3? Okay. Now you also want to move back, okay? And you also want to consider, like, this is when you take the ith guy, right? When you take I, like, this is when you take I, right? This is when you take I. But you also want to skip I. You also want to skip I. So once you return from this vertical recursive call, you will, when you get this total as 0, you will return from here, right? So you want your vector to be in the original state. You want to be you want it to be in the original state. But since you're passing it by, since you're passing it here by reference, like any changes that you'll make, that will be reflected. So when you will come back from here, then the vector will be looking like this. But do you want it to look like this? No. Please write no in the chat. Do you, when you will come back even, so since you have made changes to it, so they will be reflected when you come back. So vector will look like vector is equal to vector is having the element 3 here. But I don't want it. No, I don't want it. Okay, because I want this vector to be like this. So what I will do is, what, like, what element, whatever element I had inserted here, I'll pop. Please write pop in the chat. So I'll pop it out. Okay, I'll pop it out, and then I'll come back. So when I'll pop this 3 out, then this state will be restored. Okay, this is what is going to happen. So what will happen here, I am quickly writing that. So this will be nothing but v dot pop back, right? V dot pop and underscore back. This is what will happen, right? And this is nothing but the process of backtracking. Okay, this is nothing but the process of backtracking. Is this clear? Please write B in the chat. This is the process of backtracking. When you have inserted something, right? When you broke something or when you did something, and then you reversed whatever you did. So this is nothing but backtracking process. Okay, this is nothing but when you backtrack. Okay, whatever changes you had made, you're fixing it again. Like you're basically reversing your changes that you had made. Okay, now understand this thing. Just give me a second. Okay, now understand this particular thing here, that if you have I, the total is 3 and I is equal to this, right? So if you take I or you don't take I, if you don't take I, then what will happen? Then you will say that, okay, now if you don't take I, right? So one of the answers is stored as 3. Okay, so let me do one thing. Let me quickly put it down somewhere here. Okay, now if you will see here, suppose that if I don't take I, right? If I don't take I, then what will happen? All of you can hit the like button if you're understanding till now. I'm going to draw the whole diagram for it. Okay, this is when you'll move back. So if you don't take I, right? So you will move to I minus 1. Now see, when you don't take I, then what will happen? You will move to I minus 1. You'll call the, like, see, if you, if I was less or equal to total, then you can take it or not take it. Now if you don't take I, then you'll move to I minus 1 now. So what will happen? Now your vector is empty here. Okay, your vector v is still empty here, right? And you are having the total as 3, and now your I value is 2 in this call. Okay, now is the I lesser equal to total? Yes. So you can do what? You can either take I is equal to 2, or you can do what? You can skip I is equal to 2. Okay, you can skip I is equal to 2. These are the two options that you have here. Okay, you can take I is equal to 2, or you can skip I is equal to 2, right? This is what you can do. Now if you take I is equal to 2, then what will happen? If you take I is equal to 2, so if you take I is equal to 2, then the vector will become what? It will become nothing but 2. It will have 2 inside it. Okay, and then what will happen? Then the total updated will become what? If you take 2, then 2 will be reduced from the total, and the total will become 1. Okay, After that, what will happen, guys? Understand. Now, if you will observe, so in this case, after this, the vector will be 2. Okay. If you consider, let's say you remain at the same I, right? So I is equal to 2. So in that case, can you now, if the, like, understand this thing, right? Understand this particular thing. If the total is 1 and I is equal to 2, right? So either I can take it or skip it. So obviously I'll skip it. Please write skip in the chat. If I value is 2 and the total that I want to make is 1, so obviously I'll skip it, right? I'll skip it. Now I'll not take it, right? So from this call, this is not possible. Now what I can do is I can move to I minus 1. So I is 2. Now I move to the lesser. So I'll move to I is equal to 1. Okay. When I move to I is equal to 1, then what can I do? What can I do? I can take I is equal to 1. So when I take it, so vector will now become 2 comma 1 because I've taken 1 as well. When I take 1 as well, then what will happen? Now my total becomes what? Total becomes what, guys? 0. Please write 0 in the chat. Now the total becomes 0. The moment my total becomes 0, right? So what will I do? I'll store the current answer, right? So in my answer, what can I say? I can simply say that the answer list will now have 3 is already stored. The array list 3 is already stored. Now I'll store 2 comma 1 as well. Is this part clear till now, everyone? Is this part clear to everyone? Guys, quickly let me know. Till now, everyone is clear with it. If you're clear with it till now, you can hit the like button as well. Right. Now, since I have hit the bottom condition now, so I also want a condition when I'll have 1 1 1. So can I say that I need to make the arrays empty again, right? So basically, whatever, like when I'll backtrack now, then I'll pop this guy out. The when I'll do pop back, so the last guy will get popped out. So the this state will be restored. From this state, there is no other call. So now this, like from here also, I'll move up. Okay. So the vector will now be again empty, right? You can consider this particular case. Okay, the vector is again empty. Now, when you skip I is equal to 2, now, when you skip I is equal to 2, then when you skip it, right? When you skip it, then you have option what? You have option as I is equal to 1, okay? And the vector is still empty, okay? And the total that you want to make is nothing but 3, right? The total that you want to make here is 3. Now if you want to make the total as 3, so let's do one thing. Let me just store the answer somewhere down here so that you can always see the answer till now is nothing but 3 is stored, okay? And 2 comma 1 has been stored. Now if you will see, like this is the whole recursive diagram, you can understand. Now when you have this particular value, right? So if you have what if you have I is equal to 1, okay? Now the value that you can take is 1. The vector is still empty and you have this, right? So either you can do what? Either you can skip, like you can do what, guys? You can like see. There's one option that I can tell you. Like you can skip I. Like you can skip what? You can skip I is equal to 1. Okay, and you can move to I is equal to 0. The moment you like move to I is equal to 0, that is when you will return from there, right? This is one of the recursive calls that will happen. But obviously you don't want to even see that. Okay, you want to see the case of take I is equal to 1. When you take I is equal to 1, then in your vector you will push 1. Okay, and your total will become what? Your total will become nothing but 2. Now again you have an option, right? Again you have an option, right? Either you skip it, right? Either you skip I is equal to 1 and you move to I is equal to 0. The moment you'll move to I is equal to 0, that's when you'll simply return from it. Okay. Other than this, what is the option? Other than this, the option is that you take again I is equal to 1. When you take I is equal to 1 again, then the vector will become what? 1 comma 1, right? And then after that, the total will become what? 1, right? Here also you have choices, right? Either you take I is equal to 1 or you skip I is equal to 1. If you skip I is equal to 1, then you'll move to I is equal to 0. The moment you move to I is equal to 0, that's when you'll backtrack, right? That's when you'll move. That's when you're going to return. But if I is equal to 1, you can take it. So the vector will become what? 1 comma 1 comma 1. And when you take I is equal to 1, like then the total will become what? Total is going to become 0. And whenever the total becomes 0, then you'll store this particular vector. So now you will store this in your answer. That is list of list. You'll store 1 comma 1 comma 1 list also, right? So you'll store 1 comma 1 comma 1 as well. Okay, and then you can see that you'll move back from here, you'll move back from here, you'll backtrack here, right? You'll backtrack up, right? Then you'll backtrack here. So all the calls are done. So overall, the answer that you'll be having, it will be storing nothing but this particular list, that is 3. Then it will be storing 2 comma 1. Then it will be storing 1 comma 1 comma 1. Okay, this is what it will be doing. Is this part clear to everyone, guys? Is it clear? Just quickly let me know. Is this part clear to everyone? Let me try and compile it and see what happens. Okay. So we are not getting any output. Why is that the case? So am I missing something here? Yeah, I have not passed it as ampersand, so I should pass it as ampersand so that any changes that I make to it should be reflected finally. Let's try and compile it now. Okay, you can see that we are getting the same expected output now, because you can see first of all this particular thing 3 will be stored, then 2 comma 1 will be stored, then triple 1 will be stored. Okay, now let's try and submit this code to see what will happen, and then we'll discuss the time complexity for this approach as well. So you can see that this code gets accepted. So you can write AC in the chat. Just quickly, just write AC in the chat, because this code gets accepted. AC means accepted. So you can write AC in the chat as this code gets accepted, and then I'll discuss about the time complexity of this code as well. Okay, then I'll discuss about the time complexity as well. Okay, now let's discuss about the time complexity. If you'll observe, so it has been given as 2 to the power n. Why? Because if you will see now, if you will see, so can I say that for every I, right, for every I have, I have two choices, right? Either to take it, right? I have two choices. The first choice is either take it, okay. The second choice is don't take it, right? Don't take it, or you can say skip it, right? Skip it. So one of the choices is I can take it or I can skip it. So for every option, for one number, if I have two choices, right? So for I is equal to n, if I have two choices, either to take it or not take it. For I is equal to n minus 1 also, I have two choices. For I is equal to n minus 2 also, I have two choices. So till I is equal to 1, I will have two choices, right? So there are total n times I'm doing this. Now you can understand that I'm doing this particular thing n times overall. Like I have two choices for I is equal to n. For I is equal to n minus 1, I have two choices. So if for one number I have two choices, okay. If for one number I have two choices, and there are n such numbers, so 2 into 2 into 2 n times. So that is nothing but 2 to the power n. Is this part clear? So that is why the time complexity, okay, is going to be order of 2 to the power n for this particular approach. And we have applied the backtracking approach for this particular problem. Okay. Is everyone clear with this time complexity? Please write clear in the chat. For one element, you have two choices, right? For I is equal to n, you have two choices. Similarly, for I is equal to n minus 1, you have two choices, either to take it or not take it. So 2 into 2 till I is equal to 1. So basically, you can say that for all the n numbers, you have two choices each. So that is why 2 multiplied how many times? N times, right? So 2 to the power n is the time complexity. And we are applying the backtracking algorithm. Is it clear? Okay, and this question was asked in Amazon. I will do one thing. I'll quickly copy the code and share the link with you as well. Okay, so that you can take it for future reference. Okay, so if you're clear, you can all of you can hit the plus one and hit the like button as well, guys. If you're clear with the question till now, right? Then we can proceed further, obviously. All of you can give me a plus one if you understood it inside out. There should be no discount in terms of responses. Okay, I think this is the code now. Yeah. So now let's try and copy it and I'll share it. Could you explain the space complexity? So if you want to understand the space complexity for this question, so if you will see they are saying that you are taking extra space as order of n. Why they are saying that? Because if you see, if you don't consider the recursive space that you are taking, right? Because in the recursion, at most what will happen, right? At most what will happen? Like if I have n is equal to, let's say, 5, like if I have n is equal to 3, right? So at most how many elements am I storing at one point of time in the array, right? You can say that 1 comma 1 comma 1, that is nothing but order of n space, na? Order of n space, like whatever is the value of n based on that. Like if I have, let's say, n is equal to 5, then at most there will be a case when the array will store 1 comma 1 comma 1 comma 1 comma 1, right? So they are talking about this auxiliary extra array that you are taking for considering the space, right? So this 5 elements, so that is why order of n space complexity now, because in the worst case all the elements are one, so then 5 spaces are taking, so order of n spaces in the worst case, you can say whatever, if the n value is, let's say, 10 to the power 6 or something, like let's say if n is equal to 10 to the power 6, then you will have 10 to the power 6 ones, right? So this kind of case I'm talking about. It totally depends on the value of n, but that is why the space complexity in the worst case, the extra space that you will be taking in the worst case is order of n if you consider the vector space that you're taking. Is this clear, Rishit? And other people are clear with it? I hope that it makes some sense, right? So this was the problem of the day. It was asked in, obviously it was asked in Amazon. Okay. Now talking about today's problem of the day. So if you will observe, so today's problem of the day, we can open it, obviously. So today's problem of the day is magic triplets. So you can observe this particular problem. It says that you have to count triplets such that I is less than j is less than k, and you have to count all the triplets such that this happens. So you can try this problem out. Make sure to try it. Tomorrow, Siddharth will be taking this particular stream for this particular problem. Okay. If you understood it till now, so please make sure to hit the like button and give me a +1, and then I'll end the stream. Did you all understood the problem inside out? Uh, just quickly let me know. Many people are saying clear. Abhishek is clear. Okay, Rishit is clear. Okay, all right. AC. Others are clear. You can just give me a +1 and you can write good night in the chat, and then we will end this session as well. Okay. Garvit is also clear. Abhishek is clear. Okay. I hope that you learned something new. You can write new in the chat if you learned some new technique from this particular question and my approach as well. You can write new in the chat, and then we'll end this session as well. Okay. Naikaj is saying that he learned something new. Great, Naikaj. So with that being said, all of you can hit like after this video is over. If you found this video as useful, so please make sure to comment down understood after this video is over, and you can comment down new as well. And thank you everyone for joining for this particular session. I'll see you on Wednesday with another problem of the day. Till then, take care, good night, and keep coding, guys. And make sure to comment down understood after the video is over. Good night, take care, keep coding.